Alright, welcome back to Mass Expert video tutorials. In this video, we are going to look at the techniques for trigonometric integrals. Trigonometric integrals of trig functions like sine, cosine, and also tangents and the rest. And each reciprocal, we are going to look at it, how to take the integral of it. And not only that, we know how to integrate sine. Knowing that when you integrate sine, you get negative cos. When you integrate cos, you get sine. When you integrate tan and the rest, we know all of them. But this technique is going to deal with what is going to happen if, let's say, you have been given this to solve, and the first case is that the m and the n is odd. If the m and the n is odd, how do we do that? And also, if m and n are even, how do we do that one too? Alright? Very good. So that's what we are going to look at it in this video. In fact, it's very necessary as far as your course integral calculus is concerned. Alright, so I will need your attention very much. It's not difficult, it's just simple. Alright, very good. Now, we are looking at case 1. So case 1, what we are going to do is that we are going to look at the case where this is concerned. Alright, so what we do is that you factor sine x and use Pythagoras identity to change it to what? This form. Alright, to change it to what? This form. What we are saying is that if m and n is odd, or if m and n are even, but if they are even, the second here go with the one here, if both powers are even. We will come back to it. But what we are looking at case 1 here is that we can have the case whereby the m and n are odd. And we can also get a case whereby one is odd and one is what? Even, the powers. Alright. So what we are saying is that when it's something like that, you factor sine n out. Not only that, you can also factor cos out. Okay? And use, for instance, okay, when we are solving the question, you get to know this. So you just know that. I will explain it furthermore when we are solving the question. And use Pythagoras identity to change the sine squared s to be equal to this. Very good. So that you can get all in terms of what? Cos. If power of cos is odd, the same method. If power of cos is odd, in the same way, if the power of, here supposed to be, if the power of sine, let me correct it. Case 1. If the power of sine is odd, if the power of sine is odd, factor sine x, so you factor one of the sine x out. Since it's odd, when you factor sine x out, you'll be left with an even power, alright? And the even power, even if it's power 2, power 4, or power 6, you can use a Pythagoras identity to change it, alright? Because if you have just sine square x to left, no problem. But if you have, let's say, sine to the power 4x, we can still make here power 2, then we square this one here. So we can still get this substitution there, alright? So that is what we mean on this part, alright? Now, what if power of cos is odd? If the power of cos is odd, there is no problem. It's the same method. We are saying that if the power of sine is odd, factor sine out so that you can do substitution of Pythagorean identity. In the same way, if power of cos is odd, you do the same thing so that you can what? Do the substitution of Pythagorean identity, and that is going to be cos squared x is equal to 1 minus sine squared x. So you do this substitution what? Inside of it. Very good. Now, what if the power of both are odd? We have looked at the case whereby the sine is odd and a case whereby the cos is odd. Now, what if both is odd? Alright, that's the beauty of mathematics. We are looking at all the cases. What if power of both are odd? The sine is odd and the cos is odd. So what you do is that you pick one that will give power 2. If possible, you pick one that will give what? Power 2. If possible. We will solve an example on it and I will show you how to go about that. Oh, case 2 is here. What if power are even? Sine is even, in the same way, cos is even. How do we do that? It's not difficult. You will use half angle, straightforward. You will use what? Half angle. You will use half angle. So with half angle, if both is even, that's what we are talking about. If both is even, if m is even, n is even, you will use half angle. You know half angle for sine in this, half angle for cos in this. That's all. Very good. You are going to look at all the cases and see how the questions are going to be. So please, that make sure you jot a good note. Alright? Very good. So, first question. Let's start with our first question here. Or I should start from the middle. Alright, so in the first question, we have an integral of cos raised to the power 5x, sine raised to the power 5, here is 2s, and what we have here is 2s dx. Don't worry, the 2s there is anything. Don't be scared of it. Alright, very good. Now, so all that we are going to do is that, now you can see, here is power 3. So, which case is that? This is the case whereby one is odd and the other one is what? In fact, with this, both is what? Odd. So, we can use, therefore we say, if power of both are odd. Let's say that pick one that will give power 2. So we pick one that will give power 2. So which one do you think is to give power 2? This is power 3, this is power 5. But I would like to show you these two. You can choose to do it like this. This can give power 2, alright. How we can see that? Then here will be sine power 5, 2s dx. Then you bring that left here. Hope you can see that. This one is acceptable because the cos can give power 2. But if only the cos, the sine 2 can give power 2. Yes, it can. Let me show you. I will show you the 2. So that you not be thinking one way. Here, we can get something like this. Don't forget that the argument is the same. The arguments are the same. So, how can we get power 2 here? That is create and destroy. So you can see that it's the same thing, alright? Because they multiply this, you get the same thing. So sine can give power 2, if both is odd. Sine can give power 2, cos 2 can give power 2, alright? But you look for the one that will be easy for you, knowing that with this, the power is 3. So when you maintain the cos there to be power 2, then the rest that will be left is what? Just power 1. That one will be simple for you. Somebody will say, push one of the cos, push one of the cos. So let's push one of the cos. We get square here. 2x sine power 5 2x. Then the one that we push. Alright. Very good. Now, what do you do next? Then, in the same way, you do a Pythagorean substitution. Alright? Then you do a Pythagorean substitution. So here, then you say that but cos square 2x is going to be equal to 1 minus, I said that the 2x there is not a problem, it's just an argument. 1 minus sine 2x, just repeat it as a, square. So by substitution, we get 1 minus sine square 2x, that is this, times sine to the power 5, 2x, then cos cos 2x. Let me tell you something. Someone can choose to do this. Someone can choose to do a substitution to the 2x. Alright? You can change the 2x. You say let u to be equal to, let the u to be equal to 2x. Then you come and change everything to u. The inside is going to be u. But this one will change, the dx will change to what? Du. Alright? Because you is going to make the dx a subject. That one is acceptable. But you can maintain it inside and do it. It's not difficult. Alright? Very good. Now from here, what do we do next? Then we set our what? Our u. So here we can say that, you see, what do you think we are going to let u to be equal to? Watch. When you let u to be equal to cos, is it going to help you? When you differentiate cos, you get sine. But with what we have here, taking sine will not help you. But if we let u to be equal to sine x, but here it will not be just sine x, but what? Sine 2x. When you differentiate this, du is going to be equal to, don't forget, this. So differentiate everything. You get what? Cos 2x. Differentiate the inside. You get 2. You can multiply by it. Alright? Then you write your dx here. So you can see clearly that cos 2x dx is exactly what is here. So we just need to divide both sides by 2. So that by writing cos 2x dx, we write du over 2. You can do that substitution. You can also make dx the subject. And when you make the dx the subject, you go and do the substitution back and it will cancel it. Alright? That one too is also there. And you can also see that we are saying that u is equal to sine 2x. So whenever you see sine in here, you put what there? U. Alright. So let's continue. So having this, then by substitution we get 1 minus u squared. Hope you can see from there. 1 minus 1. U squared. Then, here we are going to get times u raised to the power 5. Oh, the whole of this is du over 2. Let's do that. Over 2 over 2. Let's cancel this. So the whole of this is du over 2 times du over 2. So the constant here is half. Bring it out. So u raised to the power 5. Hope you can see that. 1 minus u squared du. Let me change my marker. Alright, we continue. So here we get half integral of u raised to the power 5 minus this with this, we get to the power 7 du. Hope it's clear. Very good. Very good. So here we can now integrate it. You see, it's now in the proper form. So we can now integrate this one and go away. But I have for 30 times. So u power 6 over 6. Because integration is so easy. Hey, it's not plus, it's what? Minus. Integration is so easy. Power 8 over 8 plus c, because we are dealing with indefinite here. So don't forget your plus c. Alright. Now, when you reach here, then we know that our u is what? Back. Or you can still do something. And what is that? Algebra. But let's move on. Okay, so after you get to this side, you know here you get u raised to the power 6 over 2 times 6 will give you 12. Minus, then here we get u raised to the power 8 over 16 plus c. But what is sign? What is u? What is u rather? You know that u is what? Sine 2x. Not sine x, sine 2x. So here you get that u is equal to sine 2x. So wherever you see, you put that there. Sine 2x to the power 6 minus sine 2x to the power 8 plus c over 16 over 12. So finally we get sine to the power 6 2x 1 over 12 minus 1 over 16 sine 2x to the power 8 plus c. So that becomes our final answer for that question. I hope it's not difficult. You can play back the video and see how we go about it. In fact, maintaining the 2x, you see that it's not really difficult. But you can change it and later bring it. But when you start by setting u to equal to 2x, you don't need to say that u is equal to sine again. You can use w, alright? So you're going to do substitution twice. Very good. Looking at our second question, we have looked at the case where both is odd. In our second question, we are going to look at the case where one is odd and the other is what? Even. Very good. It's just simple. Let's see. Math is fun. Math is fun. Question 2. We have Sine raised to the power 3 x cos 2x dx. If this, some will be letting you learn bunch stuff of formulas and all that. Please, you don't need formula, alright? You don't need formulas to get this. Get understanding. Look at my face. Get understanding. Because you can solve it manually without using the table or the table of the formula. That's what I'm talking about. You can just solve this one, alright? Don't learn mathematics by chewing, because if you don't take you misquote the formula and that will become your end. Alright. So one is one is odd and one is what? Even. So what we are saying is that we are going to look at the case where sine is odd. A sine odd, then that's what we're looking at it. Is it the case where cos is odd? No, cos is not odd here. Cos is even and sine is odd. So simple. We look at the one that when we push there, I would like to use push. When we push, we can do a Pythagorean identity. Please, it's not this that is even, that is where you are going to do the Pythagorean substitution. It's not that. It's not that. But the one that you push, you get power through there. And that is where you use to do the what? The Pythagorean substitution. So here you see that you can get sine square x, cos square x, but the one you push will be here, sine x dx. Alright, so but 1 minus cos x, here the argument is x, you don't bring 2x. It's equal to sine square x. How do you see that? Very good. So now then we can go straight to the point to do the substitution. 1 minus cos square x multiplying by cos square x sin x dx. Then you let u to be equal to, what do you think? It's supposed to be cos. Because when it cos, everything will change to u. The way you differentiate cos, you get sine, so this one will go. So here, cos x. So the u will be equal to this negative sign. Here, negative sine s dx. But we can get the u. We know that is exactly what it is here, but the negative. So let's negate both sides. So negative du is equal to sine s dx. So what we have here is exactly what is here. So we go and do the substitution. But let's look at the case where you set u to be sine. Doing that is not going to help you. Or the case where you do the Pythagorean identity of the cos square. When you do that, everything here will change to sine. Alright? And when everything here changes to sine, you'll be getting sine 4. You're going to be getting everything to be in sine, because you have changed it from Pythagorean identity to 1 minus sine square x. So everything will be sine. So when you set u to be equal to sine, you get cos. And when will you get cos? You will do the substitution. But look at this. Look at it. The one that you push is there going to help you. So when you set u to be equal to cos, this automatically can be to do the substitution. I hope it's clear. Very good. So by substitution, we can see that here we have already set our u to be equal to cos x. So wherever you see cos, put one there, u. Very good. So we get 1 minus, but don't forget, this is the same as cos all squared. So we get u squared, then you close it, squared. Now, the whole of this one here is negative what? Du. So, by substitution, then we get negative du. Very good. So, what will be the constant in there? The constant in there is going to be negative integral of u squared 1 minus u squared du. So, this and this, u squared minus this and this, u raised to the power 4 du. Then you integrate each term. Alright? So when you integrate, very good. So when you integrate each term, you get, but don't forget the negative will pay the inside. You get u to the power 3 over 3 minus u to the power 5 over 5 plus c. So negative u raised to the power 3 over 3 plus u raised to the power 5 over 5. Hope you can see that. Plus c. Very good. So having this, you know that u is equal to cos x. So by substitution, we get negative cos x cubed 1 over 3 plus cos to the power 5 is 1 over 5 plus c. So finally, that becomes our final answer for such question. Alright. We are still journeying through and we will get there. Let's look at our third question. And with that one, in fact, we have looked at the case where both is odd. And this is the case where one is odd and the other is what? Even. We are going to look at the case where both is even and you will love it. Let's look at it. Alright, I would like to start from here. So that you can get a space right. And you can even pause the video and try to solve it. If you can come out with it. Question 3. The integral of sine power 4x cos power 4x dx. Very good. So in this case, we can all see that both is what? Even. So how do we go about it? But don't forget that the case 2 said if both is even, what should we do to that? What should we do? Alright. Half angle. So the moment you see that both is even, then half angle has to come in mind. But before the half angle comes, you have to do something. And what is that? Watch. Let's see what we are going to do to this question. Here, we can see that this is the same as sin x cos x to the power 4 dx. True or false? You can't tell me it's false. It's true. Alright. We also know that here, we also know that, watch. We also know that sin 2x is equal to 2 sin x cos x. Is that not so? That is from Pythagorean identity, double angles. This is equal to this. And if that is so, then watch. What is here is exactly, it's not all that exactly what is here, but it's only these two. So we can divide both sides by what? 2. So when we divide here by 2, divide here by 2, so we get sin 2x over 2 is equal to sin x cos x. I hope you can clearly see that. Very good. So by substitution, we can say that this is the same as this. Alright, watch. Let's move on. So integral. So we get the integral sine 2x all this over 2 power 4 dx. It's just substitution that we have done. Very good. Now here, the power 4 will affect the half here. I'll be getting the half inside here. So we are going to get 1 over 2 to the power 4 integral of. Then we get sine 2x to the power 4 ds. This is exactly what we have now. Alright. So we now move on. We know that 2 to the power 4 is 16. So 1 over 16, the integral of, now watch. We want to apply the idea that if it's even, half angle. So we are going to do something like sine 2x to the power 2 to the power 2 dx. You can see clearly that we haven't changed anything. This is the same as this. So what the next thing to do is to apply a half angle here. So back sine squared 2x is equal to 1 minus cos half 1 minus cos. Now watch. What determines this? If here is just x, here will be 2x. If here is just x, here will be 2x. But now here is 2. So you multiply 2 by the 2x here. Alright? Very good. Because it's something like no, 2x. So if the coefficient here is 1, here will be 2x. If the coefficient here is 2 multiplied here, you get 4. That is how it is. Please, always don't forget that. In half angle. So here now that we have here to be 2, we are going to get here to be 4x. Now we can see that. Very good. So let us now move on to do the substitution. So what do we have here now? 1 over 16, the integral. The whole of the inside is this. Half 1 minus cos 4x so the whole of the inside is this. Let me start here. Alright. So we get power 2 dx. So the half will affect this. The power 2 will affect the half. So you will get 1 over 16 times 1 over 2 squared integral 1 minus cos 4x dx to the power 2. Very good. So, yeah, exactly. That is what we have for that. So, what is 1 over 16 times 4? 16 times 4 is going to give you 1 over 36. 1 over 64 right now. 64. We get 64, so we get 1 over 64. Then the integral 1 minus cos 4x to the power 2 dx. So how do we go about this? It's simple, alright? What we're going to do is that we're going to apply our simple algebra. In fact, everything left here is algebra. Having this is the same as writing this 2 times. The same as writing these 2 times. Alright, then you expand, then you simplify. So just expand and simplify it. Just expand and simplify it. So when you expand and simplify it, you are going to get, please, I'm going to quote it right away. 1 multiply the whole of this multiply the whole of this. Alright? So when you do that, you are going to get 1 minus 2 cos. Don't forget the argument. 2 cos 4x. 2 cos 4x plus cos squared 4x dx. So that is what you are going to get for that. Very good. I hope it's simple. Yes. Yes, simple. Now, then we move on. So what we have here, what we're going to do is that we're going to integrate it 10 by 10. Alright? And when you are integrating 10 by 10, also something will come there, and it's just simple. It's still not difficult. That's the question I put. Let's move on. I need space. So watch. 1 over 64, the integral of this 1 over 64 is affecting the inside. So integrate 1 as respect to x. What will you get? That is going to be x. Very good. But before that, I would like us to do something. Before we integrate it 10 by 10, we can see that integrating it is easy. Integrating this is easy. Integrating this, something will happen, and that is what? Cos is even. It's not only sine is even. The fact that you are integrating the thing and it's even, you have to introduce half angle. So with that part, but cos squared 4x is going to be equal to, since it's even, half angle. Half 1 minus. I hope you can see from there. Yeah. Since I can see it from the camera, I'm sure you can also see it. Here is 4. So it's going to multiply the 2. So you get what? 8x cos 8x. So by substitution, integral of 1 plus minus 2, 1 minus 2 cos 4x plus. Now, the whole of that thing there is half 1 minus cos 8x dx. Very good. So that is what we have there. And then we can also multiply this throughout the bracket. So we get 1 over 64. I hope you are getting my flow. 1 minus 2 cos 4x plus half minus half cos 8x dx. Alright. And now we can still add this to this to get 3 over 2. So 1 over 64 integral of 3 over 2 minus 2 cos 4x minus half cos 8x dx. In fact, I want to take my time and explain this to you. Alright. So here we can see that there is no line, we don't have any line terms here. Alright, so we can now integrate each term. So this 1 over 64 will be blocking here. Integrate 3 over 2 as respect to x minus integral of this constant will come out. Cos 4x dx minus the half will come out. Integrating each term, yes, I'm repeating everything for you to understand it, alright? But when you're doing it and you get used to it, you can choose to ignore bringing it. Cos 8x, but challenge is good to bring it if only you know about it. Integrate this, you get 3 over 2x minus integrate this. Hope you know the short method. 2 we will divide what is going to be here? 4. Then integrate the whole of this, you get sine 4x. That's what you're going to get. In fact, you can write this somewhere and try and see. Integral of 4x dx. Self u is equal to 4x. Alright. du is equal to 4 dx. dx is equal to du over 4. So you see the 4 will go down. So here you get u and is du over 4. The constant is 1 over 4. Hope you can see that. Now, u du. Integrate this 1 over 4. Integrate this, what are you going to get? U squared. So you know that u is, what is u? Sorry. Here is cos u. Because the inside is the u. How we can see that? Very good. So now, when we integrate cos, we get sin u. So now we know that this is gone. We get 1/4 sin u, and the u is 4x. So that's exactly what we get here. So when close this one is already there. We are going to get sin this over 4. So divide the constant here by whatever is here. If nothing is here, it's 1 over 4. I'm giving you the technique so that you will not be doing this task. Alright? Oh, let me clean it. Minus here to the same thing. 1 over 2 dividing 8. Integrate cos, you get sin 8x plus c. Alright, very good. So, but you know that 1/2 over 8 is going to give us, okay. Alright, so that is going to be our final answer for that. You can choose to continue with it. You can choose to multiply 124 to out and see what you're going to get. Very good. So that is that. So when you multiply the 64 by 8, you're going to get 3 over 128 for this part. Then you get, for here you're going to get it to be 1 over 128. In fact, you can leave it at this and go your way. Very good. Now let's try on our last question. In fact, we have looked at all the cases. And I took my time to explain to you. You can go back and watch again in case there is any misunderstanding on some part. Very good. Now, Let's play it and see what is coming next. Alright. Now what if we have the integral of sine raised to plus 6x? What if we have a question like this? How are we going to do that? So now you can see that the power is even, alright? Half angle. By the half angle, go with sine squared, a square power. So we can write it as sine squared s raised to the power 3. So 2, 3, 6. Hope you can see that. Yes. But sine squared s is equal to half 1 minus cos squared 2s. Don't forget the coefficient there is 1. So with this, then we can go and do the substitution back into the integral. And then the whole of this is the inside, so we bring the power 3. Then after that, you can see that the power 3 will affect the half. So here we get 1 over 2 raised to power 3. After that, we will be left with 1 minus cos square. Is it square? Oh, sorry. There is no square here. So now, this is what we have. We know that 2 raised to the power 3 is 8. Then the integral here we can distribute this. Alright, so we can split one of these, 1 minus cos 2x squared 1 minus cos 2x dx. So we can get something like this. Alright, then we expand and simplify. So when you expand and simplify this, you are going to get this just algebra, so you can do it on your own. You are going to get 1 minus 3 cos 2x plus 3 cos squared 2x minus cos raised to the power 3. You can pause the video and then do it on your own. 2x dx. Very good. So 1, 2, 3, 4. 1, 2, 3, 4. Alright. So now, having this, then you can see that you can integrate this, you can integrate this. With this, you have to apply half angle. Hope you can see that. Very good. And with this, you have to also do something to this side. So let's see. 1 over 8, the integral of 1 minus 3 cos 2x plus here half angle. So it's going to be 1/2, 1 minus cos, don't forget here is 2x. So what will happen to the inside? 4x. So that is what we are going to get there. Alright. Then minus. Now watch what we are going to do here. This is off. So you can write it as this. Let's see what we are going to do. So here 1/8. Then with this, we know that we can integrate all of this. So we are going to integrate 1 minus 3 cos 2x, 3/2. 3/2 times this minus 3/2, knowing it will affect cos 4x. I hope you can see where we are getting to. Then minus so let's block this one here, dx minus the integral of cos square 2x cos x dx. So that is what we have for that part. With this, just a hotkey. Alright, so we know that we can integrate this one. It is not any problem here. But don't forget that this 1/2 will affect this. So let's bring it here so that we will not confuse ourselves. Okay. So 1/8, integrate this, you get s plus, minus, integrate this, you get 3/2. Hope you know how to do it. Sine 2x plus, this is a constant, this is a constant. And when you add that, what are you going to get? You get 5/2. You get 5/2. So let's take plus this is 5/2. So 5/2x. This we are going to get 3/2/4. What we can see that 3/2/4. And when you do that, so we are going to get something like this. 3/2 multiply 1/4 sine 4x. So that is what we get for this part, minus this part will come later. Very good. So we know that with this, we are going to get it to be 3/60. So we are going to get 3/8. We are going to get 3/8 here. Yeah. We are going to get 3/8 here. 3/8. Now the only thing left is for this side. Let's see the technique that we are going to solve for this side. Alright. So we will come back and combine this side and this side. So let's bring the 1 minus 3. Alright. So we are bringing only the integral part, and that is the integral of cos square x here is supposed to be 2. that place is supposed to be 2. Alright. So now we move on. So here what we are going to do here is that you are going to do a Pythagorean identity to this side, because at first it was power 3. Then we push one of the cos. So here we do 1 minus sine square 2x cos 2x dx. And when we set u to be equal to sine 2x, we get du to be equal to 2 cos, but when you differentiate, okay, it's cos, it's not 2, okay, right, dx. To get exactly what is here, we divide both sides by 2. So we see what we get there. Very good. So now by substitution, 1 minus u squared, then here we get du over 2. So that is half integral of 1 minus u squared du. 1 minus u squared du. So what we are going to do next is to integrate both sides. So I'm going to continue it here. Don't forget that what you are doing is just holding this part. Yeah? That's holding this part. I love it. So we get half. Integrate 1, you get u minus u to the power 3 over 3. U minus u to the power 3 over 3. That is what we get here. But u is what? We have u to be equal to sine 2x. So, half sine 2x minus sine to the power 3 2x 1 over 3. Okay, the 1 over 3 is the one there. Very good. So, what we have here means that 1 over 2 sine 2x minus 1 over 6. Don't forget, this after this. Sine to the power 3 2x. Means that when you integrate this, you are going to get this. So, the only thing you are going to do is to do the substitution back. Alright? You are going to do the substitution back. And 1 over 8 is going to affect it. I hope you are with me. Be with me and you will laugh till the end. So, that is that. Continuation of this part is this. So, do the substitution here. Half sine 2x minus 1 over 6 sine to the power 3 2x. Then don't forget, whatever here means we are done with the integration. So we bring plus c. Then we bring plus c. So I'm sure from here you can continue to simplify it, alright? So you are just left to simplify what we have in here. So this affects the inside, that affects the inside. You see what you combined, and finally, your final result is going to give you. So please, you are here. The integration is equal to this. So just multiply this by this, multiply this by this by that. Let this affect the inside. Don't forget that the negative will affect the inside. 1 over 8 will affect the inside. When you are done, you see the one that you can add and the one that you cannot add. How do we do that? We look at the argument, alright? You know that the argument here is 2x. So any sign of an argument 2x you can combine. So you can combine this and this because we have sign in the argument 2x. We have sign here, but the power is 3. So you can't attempt that. Alright. The argument of 4x. There is something like that. So you will see what you can combine, and finally this is going to be your result. Finally, your result is going to give you I need space to write the results. So your final result is going to give you 5 over 16 x minus 1 over 4 sine 2x plus 3 over 64 sine 4x plus 1 over 48 sine raised to the power 3 2x plus c. So this becomes your final result for this question. Alright, thank you. And now I would like to see you in the next video, but before that, let me tell you something. You can see the process of going through all these bunch of steps. In our next video, we are going to look at reduction formula. I normally mistakenly say reduction of order, but that is a subtopic under ODE. Not that. Here I'm talking about reduction formula. The reduction formula is going to tell you that, there is something that you can do. There is something that you can do. In case you have here to be sine raised to the power n. The power n can be anything. Or cos raised to the power 4. Or cos raised to the power n, whereby the n representing any value. Alright. With that, it's going to be under the reduction of what? Order. And also, order within under integration by parts. The reduction of order is going to give us the formula for it. So, you'll be meeting in that video to look at that. But before that, I would like to add something also. You see, what we have just looked at it now is that of sine and cos. But what about tan, sec, and the other one? Alright, so let's look at it right now before we go to the next video to look at the reduction of order as a title subtopic. Alright, so I'll be back.